Okay, so today here we have a classic Calculus 1 related rates problem. And these are often some of the hardest problems we deal with in calculus. So I'd like to walk through a very simple example. And as you can see, my setup has changed a little from the last time. I'm now recording these on my Remarkable tablet using the screen share. So I'm going to try this out. And if this video goes well, I plan to be making a whole Calculus 1 series. I'm going to try to do it in a style where you get presented the content and then right into examples, kind of like an organic chemistry tutor format. But let's go ahead and get into this problem. So the way I start these problems is always with a picture, because normally that will help you out a lot. Okay, so a spotlight is on the ground and it's shining at a wall 12 meters away. So I'm just gonna, let's create this little dot, and that's gonna be our spotlight. And then it is shining at a wall that is 12 meters away. So this whole thing is 12 meters. Okay? And it's going to be shining on the wall, something like that. We'll just do it like that. Okay, so then now the next part, a man 2 meters tall is walking towards the building. So when you're in front of the spotlight, your shadow is going to be really huge, and the closer you get to the building, it's going to keep decreasing. So what we are finding is how fast his shadow is decreasing. So how fast is his shadow getting smaller when he's walking at a rate of 2.1 meters per second. So let's just put our little stick figure in here, and let's say he's walked some distance x, and the man is 2 meters tall. Okay. So, and then we're left with one other thing which will come in handy at the end. He is 4 meters from the building, but we don't need that right now. Okay. And now we can just call this y, because that's our height. And given this is coming from the same angle, we know this part of the triangle will be equal to the big part of the triangle, if that makes sense. So this and this. Okay, so let's go ahead and set that up. So 2 over x is going to be equal to y over 12. Okay. So now what we need to do, we need to take the derivative of this with respect to time to set up our related rates problem, if you will. Okay. So, no, we'll keep it, that's fine. Okay. So, note, we'll come up here. If you don't know, 2 over x is equal to 2x to the negative 1. And that's easier to look at it through the power rule. Okay. So this part is going to be equal to negative 2 over x squared, because if you did it, you'd bring down negative 2 times x equals negative 2, which is the same thing in this case. But we're not done yet. We need to multiply by a factor of dx dt, because we know by the chain rule that's what we have to do. And then, so over here we have y over 12. So you basically bring the 1 over 12 to the outside of it, and then it's just the derivative of y, which is 1. So we're left with 1 over 12 dy dx, because it's the same thing. I just wanted to come back into the problem real quick and say, right here, I meant dy over dt. We still get the same answer, but the notation is wrong, so I just want you to keep that in mind. And here's a good place I like to look for in my problems. So we know what x is, we know what dx dt is, and we need to find dy dt. So whenever I'm on that path, I know I'm generally going in the right direction, and that's what we want to be finding. Okay. So now to just solve this, we want to multiply everything by 12. So 12 times negative 2 x squared dx dt is equal to dy dx. Okay? And now let's just plug in what we know. So 12 times -2. And we want our x to be when he is 4 meters away from the building. So just do 12 minus 4. Okay? So we get 8 squared, which is 64. And then we want to multiply that by how fast the man is walking, dx dt, which is 2.1 in this case. And this is equal to dy dx. And let me grab a calculator real quick. So we get negative 0.78. But we're asked how fast is it decreasing. So that means this is a positive number. So he is decreasing at 0.78 meters per second. Alright, I hope you liked this video. I plan to be making more of these type of problems. And if you would like me to do a whole Calculus 1 series, I would love to. I would love to have a whole calc sequence going through the very basics all up into the harder stuff you might encounter in Calc 3 and Calc 2. But for now, that's it. I'm planning to be making a few more related rates problems for now, and we'll just see where it goes. Thank you for watching.